Imagine standing in NASA's control room, surrounded by screens flickering with data from across the solar system. Suddenly, a mission that has run for nearly half a century goes silent. A spacecraft, billions of miles away, fell quiet. For days, there was nothing but static. They pointed the largest radio dishes on Earth towards a tiny point in the sky, searching for a ghost. Faintly, a signal arrived, a pure, steady tone. Voyager 2 was still alive. The silence was broken, and the connection was restored. Voyager 2 continued its epic journey. To understand this story, you have to know the hero Voyager 2. Born in 1977, it was launched to explore the outer planets. Built to last a few years, it has become the longest-running space mission in history. Voyager 2 has traveled over 13 billion miles. It is now flying through interstellar space, beyond our solar system. The probe is a marvel of 1970s technology, with computers less powerful than a car key fob. Yet, it has survived encounters with giant planets and the harsh radiation of deep space. Powered by a decaying piece of plutonium, it continues its journey. Voyager 2 is an explorer in the truest sense, traveling to places no human-made object has been. It sends back information about the mysterious region beyond our sun's influence. It tells us about cosmic rays, interstellar plasma, and magnetic fields. It is a tiny, robotic pioneer on the grandest adventure of all time. Every day, it travels to a place where nothing made by humans has ever been before. It is our eyes and ears in the great cosmic ocean. Voyager 2's journey is a testament to human ingenuity and the spirit of exploration. It is a symbol of our desire to understand the universe. It continues to inspire us to reach for the stars. Voyager 2 is more than a machine. It is a symbol of our quest for knowledge. Even the greatest explorers can have accidents. On July 21, 2023, a routine command sent to Voyager 2 went wrong. A single incorrect command instructed the spacecraft to tilt its antenna just 2 degrees away from Earth. Over a distance of more than 12 billion miles, a 2-degree tilt is a catastrophe. The connection was broken, and the spacecraft fell silent. The team at NASA knew immediately what had happened. With the antenna pointing the wrong way, Voyager 2 could not hear any new commands. It was like shouting instructions to a friend across a vast canyon, only to see them put on noise-canceling headphones. The silence was absolute and terrifying for the people who had dedicated their lives to this mission. Voyager 2 was still perfectly healthy, but it had no way to tell us. The mission team faced a difficult wait. They knew there was a backup plan. The spacecraft was programmed with a failsafe to reset its orientation in October. But that was months away. Could they really just sit and wait, hoping their old friend would wake up on its own? They had to try something. The silence was a devastating blow. The team was determined to find a solution. They knew they had to act quickly. The mission was far from over. The engineers at NASA are not the kind of people who give up easily. Faced with a silent spacecraft, they decided to listen harder than ever before. They turned to the Deep Space Network, a global system of giant radio antennas. For this task, they needed the biggest ear they had, the 70-meter-wide dish antenna in Canberra, Australia. The team's plan was audacious. They wondered if any stray residual signal might still be detectable. It was a long shot, but they had to try. The team in Canberra pointed the giant dish to the exact spot in the sky where Voyager 2 was known to be. They scanned the radio frequencies, filtering out the noise of the universe. Finding Voyager 2's tiny signal in all that cosmic static is like trying to hear a pin drop in the middle of a rock concert. It required immense patience and incredibly sophisticated technology. For days, the search continued. They were listening for the carrier wave, the underlying radio frequency that a spacecraft uses to transmit its data. Even if the data stream was lost, the carrier wave itself might still be broadcasting. Finding that hum would be the proof they were looking for. It would be the sign that Voyager 2's transmitter was still powered on and working correctly. On August 1, 2023, the breakthrough came. After days of intense listening, the team at the Canberra station detected it. A signal, a steady, continuous tone, exactly on the frequency they expected from Voyager 2. The carrier wave had been found. For everyone on the mission, the feeling was much more emotional. They had found Voyager 2's heartbeat. This heartbeat signal carried no scientific data. It was, in essence, a dial tone. but it was the most beautiful dial tone the NASA team had ever heard. Its existence meant everything. It confirmed that Voyager 2 was not dead. The relief in the control room was immense. The discovery of the heartbeat was a triumph of technology and perseverance. It demonstrated the incredible sensitivity of the deep space network. To detect such a minuscule signal from so far away is a staggering technical achievement. With the heartbeat confirmed, the mood of the mission team shifted from anxiety to determined optimism. They now knew their target was alive. The challenge was clear. They had to find a way to shout loud enough for Voyager 2 to hear. Knowing Voyager 2 was alive was one thing. Re-establishing contact was another challenge entirely. The team needed to devise a way to send a message so powerful that it could be heard by the antenna, even though it was not aimed correctly. They decided to use the Canberra antenna again, but this time, not for listening, but for shouting. An interstellar shout. The plan was to send a command to Voyager 2 with overwhelming power. They would use the giant 70-meter dish to blast a signal into space. The command itself was simple. Reorient yourself. Point your antenna back to Earth. But sending it was incredibly complex. They had to calculate the exact timing with painstaking precision. The signal would take 18.5 hours to travel from Earth to the spacecraft. Then, they would have to wait another 18.5 hours for the response. On August 4th, the team took a deep breath and sent the command. The Canberra dish focused an intense beam of radio energy towards Voyager 2's location in the sky. Then, the long wait began. 37 hours after the interstellar shout was sent, the screens in the control room lit up. Data began to flow. The shout had been heard. Voyager 2 had received the command, executed it perfectly, and turned its antenna back towards its home planet. The 2023 incident is just one chapter in Voyager 2's long and storied life. Its journey began as part of the Grand Tour, a once-in-a-lifetime opportunity. A rare alignment of the outer planets allowed a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune. Voyager 2 seized this chance. After launching in 1977, it flew by Jupiter in 1979, revealing active volcanoes on its moon Io. It used Jupiter's immense gravity as a slingshot to speed it on its way towards Saturn. In 1981, it reached the magnificent ringed planet, Saturn. Its twin, Voyager 1, had already visited, but Voyager 2's observations provided even more detail. From there, it ventured into truly unknown territory. In 1986, Voyager 2 became the first and only spacecraft to ever visit Uranus. It discovered 11 new moons and 2 new rings. The final planetary encounter was with Neptune in 1989. Again, Voyager 2 was our first and only visitor. It revealed a dynamic, stormy planet, much more active than scientists had expected. After its flyby of Neptune and its moon Triton, Voyager 2's planetary mission was over. Its grand tour was complete, but its journey was far from over. These encounters completely rewrote our textbooks. The thousands of images and volumes of data collected by Voyager 2 gave us our first close-up look at more than half of the solar system's planetary real estate. The Voyager mission was about more than just science. It was also about sending a message. Attached to the side of both Voyager 1 and Voyager 2 is a special package, the Golden Record. It is a 12-inch gold-plated copper phonograph record. It is a time capsule, a message in a bottle thrown into the cosmic ocean. It contains sounds and images selected to portray the diversity of life and culture on Earth. The hope is that, someday, it might be found by an intelligent extraterrestrial civilization. The contents of the record were chosen by a committee chaired by Carl Sagan. They tried to capture a snapshot of our world. It includes images, natural sounds, and music from different cultures and eras. It also carries spoken greetings in 55 different languages. The record comes with instructions. The cover is etched with diagrams that explain how to play it. It shows the location of our solar system relative to 14 known pulsars. The idea is that any civilization advanced enough to find and retrieve the spacecraft could use this map to locate the star system from which it came. It is a message of peace and friendship. The chances of the Golden Record ever being found are infinitesimally small. But that is not the point. The real importance of the Golden Record was for us, here on Earth. Why does this old spacecraft matter so much? Voyager 2 is more than just a machine. It's our silent ambassador to the cosmos, a symbol of our curiosity and courage. For nearly 50 years, it sent back priceless data, revealing the mysteries of interstellar space. Its journey is our journey, carrying our hopes, dreams, and message to the universe. As it sails onward, Voyager 2 reminds us what we can achieve when we look to the stars.